Hello everyone, this is Charles Dyson from the Department of Civil Engineering. So today we'll look into the topic of igneous rocks from engineering geology. So intrusive igneous rocks, this is the topic. So let's see about magma and lava first. So magma, it means molten rock which is present below the surface of the earth, and lava, molten rock, the same molten rock which is on the surface of the earth after the volcano erupts. So this is a rock cycle. So magma initially when it gets cooled down, it becomes igneous rocks. So magma gets cooled when it gets cooled, it becomes a igneous rocks, and when this igneous rock melts down, it turns back to magma. So igneous rocks, it undergoes a lot of process. So one is melting, which again becomes magma. Then due to high temperature and pressure, it gets converted into metamorphic rocks, and the process is called metamorphism. Then weathering. When it when it weathering occurs and erosion happens on the same rock, it gets into small particles which are known as sediments. And when these sediments gets compacted, it becomes into a it gets or rather it gets converted into sedimentary rocks. So and this sedimentary rock again, when it's eroded due to weathering, it becomes like sediments. Once again, it becomes sediments, and when high temperature and pressure acts on it, it becomes into or it metamorphism occurs on it, it becomes into a metamorphic rock. So igneous rocks. Igneous rocks are formed from original hard molten material through the process of cooling and crystallization. So when the original magma cools down and it gets crystallized, it becomes igneous rocks. So you have got three types of igneous rocks. So volcanic rocks, plutonic rocks, and hyperbyzal rocks. So they name it by the difference in height which is being created. So volcanic rocks formed by the cooling and crystallization of rock lava erupted from volcanoes. So the rocks which are formed above the surface of the earth, when lava gets solidified, as already I told you, lava means whichever come after eruption, the molten mass which is after eruption of a volcano, it's called lava. So when this lava is crystallized due to cooling, like it's called as volcanic rocks. So plutonic rocks are formed below the surface of the earth. That's our after 7 to 10 kilometers, between 7 to 10 kilometers, if the magma, if the present magma is like solidifies, it's known as plutonic rocks. And the last one is hyperbyzal rocks. Hyperbyzal rocks are rocks which are created in between these both volcanic and plutonic rocks, and it is known as like hyperbyzal rock. So the texture, so texture of igneous rocks. So whatever igneous rocks it is, like that's formed. So the texture, we'll see about the texture. So degree of crystallization. So it's of three types, like a hollow crystalline, hollow hyaline, and mesocrystalline. So hollow crystalline, it's a distinctly crystallized. Hollow hyaline, it's very fine in size and glassy. And mesocrystalline, it's in to intermediate. So grain size is between 1 mm to 5 mm. So depending upon the grain size, it's divided into coarse grain, medium grain, and fine grain. And fabric, it's relatively the equigranular texture fabric. So like types of texture, we'll see about the types of texture here. So types of texture, equigranular, in equigranular, then directive textures and intergrowth. So equigranular, equal in size, example granites. So it's of equal grain size. The grain size is equal in equigranular. So large crystalline size, it can contain small grains, bigger grains, and medium grains. Directive texture. Then the third one is directive texture. So it's formed by the flow of magma. When the magma flows down, and during this flow process, when it gets cooled down, the texture which is formed will be directed texture. So intergrowth is mixed up with minerals. A lot of minerals will be mixed up. So granites. So we are like this is a granite. So it's a plutonic light colored igneous rocks. So equigranular in texture composition, it contains quartz, feldspar, orthoclase, albite, and oligoclase. And accessory minerals, mica, amphiboles like hornblende, pyroxene, then augite, hyperstein, oxides of iron, apatite, garnet, tourmaline are also present in some granites. It's a granite. So granite is normally used for construction works like flooring, then foundation works. For that, you use granites. Texture. So texture of this granite generally coarse to medium grained, hollow crystalline and equigranular structure texture. Then large scale massive structure. It's like a mass. Like the mass will be very big. Types relatively abundant and it's like it's found everywhere. So next we'll see about diorite. So this is intermediate igneous rocks of plutonic origin. Again, it's a plutonic rock composition rich in feldspar, plagioclase of soda group. Then beside plagioclase, other alkali feldspar are also present. Then hornblende, biotite, and some pyroxene groups are also present in this diorite. And the diorite that's given here, the photo of this diorite, quartz diorite. It's a quartz diorite. Texture. Again, it's closely resemblance to granite. It looks almost to a naked eye, like naked eye, it looks like a granite. Then occurrence small dike silts, it occurs. So the types of diorite. Then next one is cyanite. So these are igneous plutonic rocks which are even grained rocks. These are also known as even grained rocks. So alkali feldspar, then orthoclase albite is present. Dark minerals like biotite, hornblende, augite are also present here. Biotite is nothing but black mica. Composition, common feldspars like orthoclase, albite are also present here. So it's so beautiful colors like blue, then gray colors are also present here. So it's a coarse to medium grind holocrystalline structure. Then types based on the presence of dark minerals. So here we'll have a lot of types here. Next one is capro. So coarse grained, it's a coarse grain. You can see with the naked eye itself, it's coarse grained. The grains are coarse and it's dark colored plutonic rocks. So here plagioclase feldspar of lime soda composition is present. Then accessory minerals, augite, hornblende, olivine, biotite, and iron oxide is present. So its texture is medium to coarse grained. So here a few types are given. Then dolerite. It's a picture of dolerite is given here. So it's igneous rocks of typical hyperbasal origin. So again, hyperbasal is intermediate rocks. It's neither a plutonic or a volcanic rock. It's a hyperbasal is present between these two. Then composition classic plagioclase is present here. Dark minerals like augite, olivine, and iron oxide are also present. So texture is fine grain to medium grain. So by this itself, we can see if you put it under a microscope, you can see the grain size clearly. So this is basalt. This is picture is basalt and volcanic igneous rocks cooled from lava flow. So it's lava flow. It's like again above the surface of the earth, and it will be again a fine grain, very fine grain. So it's almost like grains is not visible to our naked eye. And this is pegmatite. So the pictures of pegmatite is given. So again, pegmatite. Yeah, here you can see the pores here, and this is above the surface of the earth. The volcano eruption picture is given, and after eruption, the lava starts to flow, and you can see flowing here, and a few areas it has already started to cool down, and cinders. These rocks are also known as cinders.